this video, we're going to prove the following fact about this new function rho. We're going to show that rho is a multiplicative function. And rho is defined as follows. Rho of 1 is equal to 1. And if n is bigger than 1, rho of n is always base 2 to some number r. What is r? R is equal to the number of prime factors that make up the prime factorization of the number n. For example, rho of 8, since 8 is 2 cubed and it only uses 1 prime, it's 2 to the number of primes, which is 1. If you take rho of 2 cubed times 3 squared times 5, let's make that 2 squared. 180 if I'm not mistaken. So rho of 180, first thing you do is you write it as write it in prime factorization form. And then rho of that is going to be 2 raised to the 1, 2, 3 prime factors. We don't care what those powers are. The answer is 8. So here I won't bother multiplying out the number. But if you have rho of 7 to the 5th times 11 to the 13 times 17 to the 14 times 23 to the 1, this will be 2 raised to the 1, 2, 3, 4 powers. Whatever number this is, let's just say it's 2050. I'm sure it isn't, but let's say it is. You take 2050, you write it in prime factorization form, which I am saying most probably incorrectly is what's in the brackets here. 7 to the 5 times 11 to the 13th, etc. Just count the primes. 1, 2, 3, 4, 2 to the 4, 16. So I want to show that rho is a multiplicative function. And to see mathematical proofs like this, you should consider subscribing to my channel. So let us pick an n. Let n equal p1 to the k1 times p sub 2 to the k sub 2 all the way to p sub r to the k sub r be the prime factorization of n. Okay. And m is equal to q1 to the L1 times q2 to the L2 all the way up to qs to the ls be the prime factorization of m and n. Also assume that m and n are relatively prime, because that's a necessary condition to say something is a multiplicative function. Rho of mn can be multiplicative, but it doesn't equal to rho of m times rho of n. That's not true, always true, that they're equal. Rho can be multiplicative, but rho of mn does not equal rho of m times rho of n. However, if rho is multiplicative and m and n are relatively prime, that is, their GCD is 1, then yes, that equality holds. So also assume that the GCD of M and N is 1, which implies that no P sub I is equal to a Q sub J. Okay. So now rho of NM is rho of N, P1 to the K1, all the way up to P sub R to the K sub R times M, which is Q1 to the L1, all the way down to QS to the L sub S. Okay, now no QI equals a QJ. Okay, so how many primes do I have? 1, 2, 3, 4, R. And I'm adding 1, 2, 3, 4, eventually S. This is 2 to the R plus S. But this function is multiplicative. That's and R and S don't even have to be relatively prime. That equals 2 to the R times 2 to the S. But 2 to the R, well, that's 2 to the R. Rho of that is 2 to the R. I can use a different function that has R distinct primes, but I'd be foolish if I did that. You'll see in a moment why that would be foolish. Times, so this here is 2 to the R distinct primes, times rho of 2 to the S. That means I want what's in here to have S distinct primes. Well, that's Q1 to the L1 up to Q sub S to the L sub S would suffice. Now, the reason I use these R primes is because what I just underlined is N. The reason I use those S distinct primes was because that product is M. So I did verify that rho of NM is equal to rho of N times rho of M. Given that M and N, the GCD is 1. And that completes the proof. Don't forget to save this part. Otherwise, your proof is not valid. Because it doesn't need to be true. Well, maybe in this case it will be true even if M and N are not relatively prime. I kind of said that from here to here, but since we're talking about showing that phi is a multiplicative function, we should state that the GCM is 1. If you like seeing mathematical proofs like this, seriously consider subscribing to my channel. Hit the like button. Tell your family and friends about this channel. See you guys in the next video. Don't forget, watch and learn.